Good morning, dear students. My name is Ferhan Mazher, and today is 25th of May 2021. The subject we are studying is Physics 5054. It's O levels physics, and we are studying the chapter of current and electricity. This is the fourth lecture on this chapter. And today we are going to talk about a very important physical property of the conductors and the insulators, that is called the resistance. So, resistance of anything, we will have a little bit discussion on this topic. So, basically, the resistance means that whenever you try to pass current through any material, the material will not let the current pass through it. So what do I mean by this? That when you try to pass charged particles through a material, so the material will oppose the motion of those charged particles, and the motion, the opposition, or which is to the flow of the charged particles through a medium, that's known as the resistance of that material. So the property of a substance which offers opposition to the flow of current through it is called its resistance. When I say the resistance of this copper wire, I means that actually what does this mean? This means that that copper wire will try to oppose the flow of current through that the piece of copper. So that's known as the resistance. This opposition comes from the collision of the moving electrons with the atoms of the substance. Obviously, we know that the current is basically due to the flow of the charged particles, and the main charged particle will be electron. It could be positive charges, it could be negative charges, but let's say the flow of electrons is causing the current. So those electrons will collide with the atoms, and their flow will be stopped, or they will feel opposition to the flow. So they are trying to pass through the copper wire, and when they collide with the atoms of the copper, they will feel opposition, they will feel resistance. So the opposition which is provided to the flow of the charged particles, that is known as resistance of that substance. Resistance is, we have a unit in the SI system, the system international. The unit for the resistance or the opposition to the flow of the charged particles through a medium, that resistance, its unit is ohm, OHM, ohm. And the symbol used for that is this horseshoe. You can see this horseshoe symbol. It's a very important symbol. Don't forget this. So resistance is measured with the unit ohm, and the symbol is this horseshoe. You can see this horseshoe. The SI unit of the resistance R is ohm. If we put 1 volt and 1 ampere, the value, if you have, for example, suppose, for example, this is a copper wire. Suppose this is a copper wire. And if 1 ampere current is flowing through it, if 1 ampere current is flowing through it, and the voltage drop across this is 1 volt, if the voltage drop across any copper wire or anything is 1 volt, and the current flowing through it is 1 ampere, then the resistance of that thing will be 1 ohm. You will understand this the next slide. When a potential difference of 1 volt is applied across the ends of a conductor and 1 ampere of current passes through it, then its resistance will be 1 ohm. So that's the definition of the resistance and the the unit which is used to measure the resistance. Okay, for example, if you want to measure this diagram which is showing up on your screen, if you want to measure the resistance, for example, if you have a piece of copper wire and you want to measure how much is its resistance, or if you have a resistor, we will study in detail what are the resistors. Resistors are basically a simple component, and it's represented with this rectangle on the circuit diagram. And what they do, they convert the electric energy into heat energy. They convert the electric energy into heat energy. So they are called resistors. So if I want to find out the resistance of this resistor, what I will do, I will connect it with the battery. I will connect the ammeter, and you know the ammeter is always connected in series with the resistor, and I will put a voltmeter across the resistor. So one this V1 voltmeter that will measure the voltmeter is always connected parallel so to the resistor. So this voltmeter will tell me how much voltage is taken by this resistor, and this ammeter will tell me how much current is flowing through this resistor. So if I want to find out the resistance of this resistor, very simple, just connect them, switch them on, and whatever will be the reading on the voltmeter and whatever will be the reading on the ammeter, divide the voltmeter reading with the reading on the ammeter. The voltmeter will be giving you the voltage used by that resistor, and the ammeter reading will be telling you how much current is flowing through that resistor. So voltmeter reading divided by the ammeter reading, and that will give you the resistance. If I represent the resistance with the capital R, so very simple experiment. This is how you will measure the resistance of a given resistor. Here you can see I have shown another diagram. I have tried to show another diagram. In this diagram, you can see that I have a resistor, same resistor which was in the previous example, and I have connected an ammeter. The ammeter is connected in series with the resistor. The voltmeter is connected parallel to the resistor. Here, I have connected two cells, two batteries, and they are connected in such a way. Now the voltage will be more. Now the voltage or the EMF of the source or the battery has larger voltage. Now switch on this thing and note down what is the reading on the voltmeter, note down what is the reading on the ammeter. Simply divide the reading of the voltmeter with the reading of the ammeter, and that will give you the resistance. So resistance will be V2 divided by I2. V2 means the reading on this voltmeter, and I2 means the reading on this ammeter. So very simple way of measuring the resistance. So till now we have learned just few things. One, what's the definition of the resistance? Resistance is the opposition to flow of the electric current through a medium. That's the resistance of that medium. Second thing which we have learned is that the resistance is measured in ohm. And then we learned the definition of 1 ohm. 1 ohm will be if a current of 1 ampere is flowing through a component and the voltage drop across the component is 1 volt, then the resistance will be 1 ohm. The next thing in these two slides which we have learned is how to actually measure the resistance of a component of a resistor, I can say. And that is, you connect it with the battery, you put an ammeter with it, ammeter is connected in series, and voltmeter is connected in parallel. You switch on this circuit, divide the reading of the voltmeter with the reading of the ammeter, and that will give you the resistance of that component or that resistor. So here I have connected a single cell, and here I have connected two cells to change the value of the voltage and the ammeter. To your surprise, if the same resistor is used in both these diagrams, whatever will be the reading here, V1 by I1, same will be the reading here, V2 divided by I2. We have changed the voltage of the battery, EMF of the battery. The current value will change, the voltage value will change, but the R, you will get the same thing. So these are the few points which we have learned up till this point. Can anybody tell me these points again? Anybody would like to tell me what you have learned? Hello? Hello?
सर मेरा एक क्वेश्चन है जो रेजिस्टेंस की वैल्यू है वो क्या है
Resistance value you can, what do you mean by value? You
ओह
can
सॉरी
find
आई
out
मीन
the
यूनिट ऐसा यूनिट
SI unit is ohm. Ohm.
Okay.
Remember Om Shanti Om? This is Om. OHM Om. And the symbol is that horseshoe. Anybody would like to repeat what the points which we have learned up till this point? Hello, are you listening? I think that's okay. So if you do the same experiment here, we have a numerical solved, and in this numerical, you can see that the reading on a voltmeter connected across a heating element is 60 volt. The amount of current passing through the heating element measured by an ammeter is 2 ampere. What is the resistance of the heating coil of the element? And I told you that divide the reading of the voltmeter with the reading of the ammeter, and that will give you the resistance. The reading on the voltmeter is 60 volt and the reading on the ammeter is 2 ampere. So 60 volt divided by 2 ampere, and that will give you 30 ohm. 30 ohm will be the reading, and kindly do this example. And okay, do you understand this example?
G.
Okay. So the formula which we used is very simple, that the resistance is equals to the voltage, whatever the reading will be on the voltmeter divided with the reading on the ammeter, means voltage divided by current, and that gives you the resistance. Okay, so let's move to the next point, the resistance. We will now learn to drive a formula for the resistance. You know, the resistance or the opposition to the flow of the charges, that depends upon the length of the material. If the resistance is directly proportional to the length of the conductor, to the length of the wire, the length of anything whose resistance you are talking about, resistance is directly proportional to the length of that thing. The longer the length, the larger will be the resistance. So if the smaller will be the length, the resistance will be also smaller. In other words, if I use the mathematically, if I say the word directly proportional, it means if the length will become double, the resistance will also become double. If the length of the conductor will become 3 times, or the length of the resistor will become 3 times, the resistance will also become 3 times. So the resistance of a resistor or a conductor or a wire depends upon the length. The larger the length, the larger is the resistance. Smaller the length, the smaller is the resistance. R is directly proportional to the length. In the same way, the resistance is inversely proportional to the cross-sectional area. The cross-sectional area of the conductor. The resistance is inversely proportional to the square. I wrote here square by mistake. This square should not be here. It's not square. Uh, just give me a minute. I made a mistake. There, here. Let me move this. I by mistake wrote there square. So this square should not be here. Square is not square. This square is not here. So just give me a minute. By mistake, I have written there squares. So this square is not here. Just give me a minute. And give me a minute and I will I by mistake wrote here. I by mistake wrote there square. The square is not there. Okay. Let me, because if it's very important that just now it's good. So we were talking about the resistance is inversely proportional to the cross sectional area. So cross sectional area means if this is the conductor wire, for example, this is the conductor wire, so this is its cross sectional area. So the resistance is inversely proportional to the cross sectional area. It means that the cross sectional area, if the cross sectional area will become larger, the resistance will become smaller. So if the wire is thin, its cross sectional area is less, its resistance will be high. If the wire is the wire is thick, then the resistance will be lower, because the resistance and the cross sectional area, they are inversely proportional to each other. If we combine these together, so R is proportional to L by A. When I remove this proportionality sign, I introduce an equal sign here. I have to use a constant here. You must have learned this in your mathematics. So that rho, this constant here is rho, and this is known as the resistivity. This is known as the resistivity. So formula for the resistance is rho L by A. Rho L by A. Rho L by A. So here I was trying to explain to you, if for example, these are two same material, same conductors. If the length is L, and in this second diagram, you can see I have doubled the length. When you double the length, the resistance will also become double. If the resistance of this wire is R, when the length will become double, the resistance will also become double. Because the resistance is directly proportional to the length. And here you can see that the cross sectional, here in these two diagrams, I'm trying to explain the connection between the resistance and the cross sectional area. If here the cross sectional area, here in this diagram, the cross sectional area is A, and in this diagram, the cross sectional area has become double. If the cross sectional area will become double, the resistance will become half, because the resistance and the cross sectional area, they are inversely proportional to each other. So basically here we have found a formula, another formula. One formula was R is equals to V by I, the ratio between the voltage and the current. And another formula for the resistance is rho L by A, where L is the length of the conductor, A is the cross-sectional area of the conductor, rho is resistivity. So we will learn about it. Okay. So this is another experiment shows that the resistance R of a wire of a given material is directly proportional to its length. So R is proportional to L, inversely proportional to its cross-sectional area. R is inversely proportional to 1 by A, proportional to 1 by A. Doubling A has R. Combining these two statements, we get R proportional to L by A, or R is equals to rho L by A. It's the same thing which I just taught you, where rho is a constant called the resistivity of the material. So resistivity of the material is, if the length is 1 meter, how you define the resistivity? Resistivity of the material is numerically equals to the resistance of a 1 meter length of a material with cross-sectional area of the 1 meter square. The resistance of a substance when its length is 1 meter and its cross-sectional area is 1 meter square, that the resistance at that time will be known as the resistivity. Remember the resistivity of any substance, a rho resistivity, that is is a nature of the material. It does not depend upon the dimensions of the length and the width, and it does not depend upon the dimensions of the material. Resistivity of a material depends upon the nature of the material. That's why the resistivity can be also used to identify different metals, different materials, because resistivity of a material is unique for every material. Okay, so the unit of the resistivity is ohm meter. The resistivity is, if you make the R, you see the if this formula, from this formula, if you make the rho alone, if you make the rho subject, or for example, here in this formula, if I make the rho alone, this A will go upstairs, this L will go downstairs. So rho will be equals to A multiply R divided by L. So here we're talking about this thing. The unit of the resistivity is ohm per meter, as can be seen by rearranging the equation to give ohm is equals to rho is equals to AR by L. And in inserting unit for A, R, and L, knowing rho for a material, the resistance of any sample of it can be calculated. The resistivities of metal increases at higher temperatures. For most other materials, they decrease. For metals, if you increase the temperature, the resistivity will increase if you increase the temperature. So, so this is how you will measure the. This was all about the resistance. So we will have to continue with this. So if you have any kind of question, you can ask right now, because the resistance topic is not yet over. We will continue discussing about the resistance. So if you have anything, we can. Do you know what we have learned today? Can anybody give us a review?
सर अभी आपने रेजिस्टेंस का पढ़ाया, वो वेरिएबल कैसे हो सकती है और उसका रिलेशन इनवर्स से डायरेक्ट है लेंथ से और एरिया से.
Okay. So
सर आपने
what about this?
रेजिस्टेंस का मैं फॉर्मूला बताया था, और फिर आपने यूनिट ऑफ रेजिस्टेंस बताया था, और फिर आपने लाइक उसका बताया था कि आर जैसे प्रोपोर्शनल होता है एल के, और इनवर्सली प्रोपोर्शनल किन चीजों के होता है, और उसके बाद आपने रेजिस्टिविटी का बताया था.
Okay. So today we have learned about the resistance and how to measure the resistance by using voltmeter and ammeter.
सर आपने ये भी बताया था कि अगर किसी और सर्किट में आप वही रेजिस्टर रखोगे तो रेजिस्टेंस जो है वो सेम रहेगी, हालांकि वोल्टेज और जो फ्लो ऑफ करंट उनकी वैल्यू डिफरेंट हो.
Yes. So these are those two diagrams. The resistance you can measure by voltmeter reading divided by the ammeter reading. The amount of voltage drop across a component divided by the current flowing through it. You can find out the resistance. And then we talked about this example. One example. This is that. Okay. So this is the next formula, that is R is proportional to L, R is inversely proportional to the cross-sectional area. We combined it, resistance is equals to rho L by A. And here I was trying to explain you that how the things will change. If you double the length, the resistance will also become double. So length and resistance directly proportional. Cross-sectional area and the resistance, they are inversely proportional. And then we have combine those factors, and the formula is R is equals to rho L by A. So here we got the resistivity. So one very important thing, that for resistance we have two formulas. One formula, resistance is equals to V divided by I. V means the voltage drop across that component, and I means the current flowing through that component. Another formula for the resistance is rho L by A. Rho L divided by A. So where rho is the resistivity of that material and L is the length of that material, or that component or that wire, and A is the cross-sectional area of that material. So these are the few basic things we talked about the resistance. So hopefully you have, yeah.
Sir, how can we differentiate between resistance and resistivity?
You see, the resistance, um, resistivity is the resistance of that material when its cross sectional area is 1 meter square and its length is 1 meter. Then the resistance will be known as resistivity. Whereas the resistance, its dimension can be any dimension. For example, the dimension might be just the cross sectional area might be 2 meters square. The cross sectional area might be 0.002 meters square. But if the dimensions are area is 1 meter square, area is 1 meter square, and the length is 1 meter, then whatever will be the resistance, that is known as the resistivity. And you know, the resistivity of a small piece of copper, a big piece of copper, a very big piece of copper remains, resistivity remains same. If I, for example, I can give you, if I take a small piece of copper, check its resistivity and check its resistance. Okay, now take a larger piece of copper, a longer piece of copper. Its resistivity will be still the same, but its resistance will become larger. Now it take a larger piece of copper, longer piece of copper. Now the resistance will be different, but resistivity is still the same. Resistivity is like, it depends upon the nature of the material. Resistivity can be used to identify a material. Okay, it depends upon the nature of the material. Okay, do you understand?
Yes, sir.
Okay, so here I have just one note. It was very important one note which we can study. A resistance, as the name suggests, is the measure of how difficult it is for an electric current to pass through a material. Copper wire, let's say, so it is basically the restriction or resistance of a material to the free moving electrons in the material. If you compare it with the friction in moving objects, it's quite correct. Now, in more scientific terms, resistance R of a component is the ratio of the potential difference across it to the current I flowing through it, such that R is equals to V divided by I. Where R is the resistance, V is the potential difference across the component. Note that across a component that is between 2 points, it's the potential difference and not EMF, and I is the current flowing through it. The SI unit of the resistance is ohm. Resistance is measured using a conductor called a resistor. Resistors are of two types: fixed resistor, variable resistor. This we will study further what kind of resistors do we have, but till now I think this is enough today. So I hope that it's been a useful thing and you have learned a little bit about the resistor. And this was I think the fourth lecture on this chapter. So it's very important you follow me, because whenever I do a lecture, I will record it and I will send you that recording. So it's very important. It is very, very important that you keep the record that which videos I'm trying to share with you. So I think that's enough for today. And so thank you very much, everybody, and have a good day. God bless you.